recording. Yay! That was a syllabus. Now we're moving on. So, we're finishing up the chapter 6 and 7 stuff. Just as a quick recap, we're doing GeoGebra. We're finding probabilities, and in this particular section, we're finding them given that we have a sample size. So all we're doing is changing our standard deviation formula a little bit. And so the mean is the mean, like that never changes. But our new standard deviation, is like the old standard deviation that they give us, divided by the square root of n, square root of the sample size. Okay, so that's kind of just a real quick recap of what we're doing there. All right, and let me get GeoGebra up, because we're going to be using it right now for sure. GeoGebra.org/classic. And here we go. Yay. Aren't y'all excited? Whee! I would run. Whoa, that would be crazy. Yeah. I almost did trip there. So, we have a milk machine, has a mean of 64, a standard deviation of this much. We now have 40 containers. And from those 40 containers, we have this much as the average. Of those 40, is there a problem? That's kind of like the lumber cutter problem we finished with last time. We just want to see what's going on with the numbers we have. Okay, so what do I put in for the mean? What's the number? 64 does not change. Standard deviation, what do I put? 0.11, yes. Yeah. Divided by square root of the 64, or 40, square root of 40, sorry. You're right, square root of 40. That's our new formula. And so, yeah, the mean, I'm going to write this stuff down, is that 64. The standard deviation is that 0.11 divided by the square root of the 40. Okay, so those are the two things we have. Now they're saying the mean is at 64.05. Is it too much, essentially? And so let me just draw a quick little thing here. We got 64, and so like right here is going to be that 64.05. At least that's what I'm imagining. 64.05. That's what I'm imagining. It's only right there, just a little bit, right? Not too much. But let's go and actually look at where it really is. If you notice here on this number line, it's like way over here, isn't it? You see that on the number line, right? It's kind of crazy over there. I want to know, is it unusually too far? Like, I want to know this area right here, essentially. Is it 5%? Is it more than 5%? So I'm going to do this picture, and I'm going to change this here to the 64.05. And see, that's where we thought it was, right? Again, it's far, far over here on the number line because our new standard deviation. Look at that probability. So like from this probability here that I got is 0.002. In percentage, what would that be? Is that 2%? No, what is it? Yeah, 0.2%. Wow. I'm going to ask, is this unusual? Yeah. Ooh, whoa. Okay, yeah, there we go. Unusual? And you're going to say, yeah, that's unusual. That's like crazy. Do you remember that 5% is unusual? Or less, 5% or less. We got point reset. Yeah, something's off. Basically, you can have one, I don't know, what is this, a gallon, a set of what kind of milk are we talking about? Container. We have one container that's 64.05. That's fine. Toned down a little bit. Making sense? Okay, good. So I don't know what else. Explain. I explained. There we go. All right. Average library patron reads 42 books a year. Oh my gosh. That's the average, guys? Who in here reads 42 books a year? Come on. You get pretty close, right? You do? For reals? Do you want to tell me what kinds they are? Okay. That's cool though. That's good. Good reading. Yeah, I don't read 40-something books a year. I'm happy to read like 4 a year maybe. But okay. That's cool though. It's a good hobby, good pastime. Yeah. It's like better than the movies, isn't it? Totally. See? I know. I just don't do it as often. Maybe, okay. Very good. 42, and a standard deviation of 10. So it says the library would like to reward the top 25% of patrons with, like a reward of some kind. So who would those people be? How can I know the cutoff line? Like the boss says, like, look, you're working for a library. They're saying, hey, look, we've got an average, we've got a standard deviation. We need to reward the top 25%. And you're just like, what do I do? We're not just going to cut it flat. We got to go and use some math to figure out that we're not giving away too many awards, essentially. All right, so let's do that. I'm going to put them in. Oh, here's the last one. I'm sorry. 100. There's only 100 people at the library. So, anyways, what do I put in the mean box? 42. Okay. What do I put in the standard deviation box? 10. Perfect. There it is. Square root of 100. Yep. Exactly right. We have our original standard deviation, high, and then we have divided by the square root of n. Now, they're saying the top 25. And if you think about the top 25, I'm going to draw a small picture for top 25 here. I don't know, something like this. So that's the top 25% right there. Sweet, right? Well, where would I have that cutoff line? And that's what we're going to find here. If you go into this box, not over there, but this box right here, and put in 0.25. And does the picture look about like the top 25%? I mean, roughly, yeah. So their cutoff line is then 42.67 for the average of the 100, okay? So here's the interesting thing. They're saying that this is 42 and that this is 42.67. Interesting. I know, that's exactly right there. Huh? Again, though, we're looking at all top 25. Yeah, something's a little wrong. It doesn't feel right, doesn't it? And so that's okay. That's okay. It's not wrong. It's necessary. It's more like we need to understand what the problem is. Okay. And I'm going to tell you straight up, I was a little too ambitious. Isn't that what we do here? We just say, put the numbers in, get the answer. But we have to read what the problem was. Look right here. They're asking us different things. And I know this 1 and 2 looks really weird. Just kind of ignore that. They're saying, what is the new standard deviation? What is the mean? And I just need to put them in this boxes and be done with it. That was it. That was the whole entire thing. What is the mean for this? 42? I like that. What's the standard deviation? It's that thing. But I have to probably figure that out because they're going to want that. All right. And yet again, this is another problem. I'm going to use Desmos right quick. I am not going to get the right answer again. Oh, look at that. 1. The answer is just 1. I'm going to guarantee you that this 42 is wrong. They're looking for a different number there. And it might be that 42.67. What I want to do is I want to go to the homework and see what they're trying to get at, okay, for this particular problem. And I'm going to come back to it if that's okay. Now, I think that we've done a lot of good work. Everything looks great. And they might just be the 42.6 whatever, but let's go. So what I'm going to do is instructor cheat my way to the top. Okay, as long as I got a grin once in a while. Yeah, I'm going to instructor cheat my way to the top here, and let's see. We're going to preview. Okay, we're going to get back to these later. Instructor cheat, keep going. I want to get to that problem. Nope. Keep cruising, keep cruising. We'll see all this again. I'm going to come back to it, but Ooh, that looks really cool. And there's no instructor cheat. It like blinked out on me. We'll get back to that later. Don't worry. Don't worry. We'll come back. Oh my gosh. Instructor cheat. Yay, we did nothing. Here we are. Here we are. Okay, let's pause. Get out of the way, Toast. Toast. Move. Thank you. Okay, its name is Toast. Just letting it. Did you know that? Actually, oh, you know what? That makes sense because it pops up. Mind blowing, bro. I always wondered why it was called Toast. I didn't call it Toast, but that's funny. Okay, that's hilarious. Thank you. Oh, really? No? Is his name called Toast? Thank you. I haven't played Mortal Kombat in a while. Anyways, so let's just look at this problem and understand what they're looking at. Notice that it has that little sigma x thingy and this the mu x thingy. It's pretty close to what we have here, right? This little sigma x thingy. Pretty close, pretty close. But if you notice, there's a difference. They're here, they're looking for this x bar. Rather than here, they're looking for the mean. Straight up. Let's do this. It's an easy problem. So, we have an average. Bingo player earns $9 a game. What's the mean? What's the average? 9. That was easy. Does not change. But this one will. It says standard deviation of 8 divided by that 25, right? So here we go. I've got the 8 divided by the square root of 25. That's just our new standard deviation. And there we go. Very simple. But the main point is that they're asking for, yes, this sigma, but mu, not x bar. Are y'all okay with those two numbers? That's pretty straightforward. We had done that a lot already. Okay? See a difference now? There's a lot of stuff going on, right? Let's do this. This is the kind of style that we're going to be seeing here in a second. So the average of 13. Average of 13. What do I put here? 13. Very good. Thank you. Standard deviation of 5. 5. Notice that it's like the old standard deviation, the original one. What's my sample size? 45. Now this is the new mean. But does the mean change? What should I be putting right there? 13. And then my new standard deviation, this is the one that changes here. 5 over the square root of 45. What does it say? Whole number, decimal? 7. Oops. What am I typing? 745355. What do they want? Just the nearest whole number? I'm a little nervous. 1? Okay. Wow. Okay. Still, no big deal here. Okay, I'm gonna instructor cheat because I want to get to the one that has the X bar on it. Hello. Still nothing. Still the old stuff. Hey, I did nothing. Thank you. So they want the old mean or the new mean and the new standard deviation. Ignore this whole table. I'm going to come back to the workbook. I'm just looking for the one that we're looking for. So we have a mean of this much. So I put it in there, 150. Standard deviation of 25, but what's my sample size? So 25 divided by the square root of 52, 3.46, whatever. 7, rounded. I don't know if they want two decimal places. 3 decimal places? Oh, look, it's dollars and cents. That makes no sense to me. I know. Gosh, I wore out all that, stuff a long time ago. Chad, you're not funny anymore. Okay. So 3.469, and notice they say between these two numbers. Right here, you just put the two numbers in. Like we've done all this. This is not the hard part at all. I'm trying to get back to the other ones here. 728. Oh, 3 decimal places. You know how they're good. Start griping at me. Did I use this table? Neither will you. I hope not, at least. No need for that. Okay. Oh, I can't. Oh, no. See, that's just the old style there. We're going to cheat. Keep cruising. We can come back another time. There it is. There it is. Right? Finally, we're actually looking at a bug. Did I catch him or did I just swat him? Anyways, so let's see if the theory is correct or not. It says to find this x bar. To me, that sounds like the mean. And does the mean change? No. So I want to put in the average. It says we get on average 7.45. I'm being silly here. It's probably not going to work, but we can try it. Standard deviation. What's my standard deviation? 0.65 divided by the square root of 30. Very good. Okay. 0.1186. 2 decimals. Okay, and then a z-score. Now, this is kind of a little weird. I need to find the z-score for, right here, the top 1%. Top 1%. So real quick, I want to draw for this. And I know, yes. Just real quick, I want to draw what top 1% looks like. Are you ready? It looks like this. Yes? How do I find that from here? Well, I'm going to restart it, refresh it, 0 and 1, and I'm going to change this and make it only the top 1%. Notice though, okay, because they're only wanting z-scores, it's kind of like they're wanting a standardized answer, like empirical rule stuff. And so I'm going to suggest that this is 2.33 if you round it. Let me get it wrong. So why am I wrong? Let's hit it again. And see the numbers different. This one right here. See? Okay. How do we get the 773? It's very close, but off by a little bit, right? So let me go and try all of the numbers that I had originally. So I had my mean was, what was my mean? 7.45. Standard deviation, what did I have again? Perfect. And then I want the top 1%. Top 1%, right? That little guy over there. 773. There it is. So what are they wanting with this X bar is actually the answer that we actually got. I was being ambitious. I was jumping in. I was like, hey, let's do all this. And it looks a little odd, doesn't it? Let me go back. What did we get here? The 42.67. That's what they wanted. Interesting, right? So what does it mean? What does this 42.67 represent? Well, it's for the top 25% of patrons, the average of the 100s of the 100 that we have there. Yes. Or would it be that every patron's a top 25 and then we're saying 100 of them? I don't know. That's the cutoff line. There you go. Are you happy we're good? Blah, 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 math. But can we get the answer right? Okay. No? Hopefully, too. So here, let's do it all over again, and hopefully this... See how it's like drawing? It's really weird. Let me try to erase. And can I draw again? And, okay, yeah, it's fixed. Okay, you're going to help me. This is all the same stuff that we just did. First off, what does my mean? Yep, exactly. 1,250. What's my standard deviation? Bigger box. 12, yes, very good. That's what I'm going to be putting in there. Yes. Okay. And then it says lower 33 or upper 67. One or the other, right? I'm going to just do the lower 33. What does that even look like on a picture? It looks like this. 33% over here. Cool so far? So what is the X bar? They're saying, what is the cutoff line? What's the cutoff line here for the lower 33%? So let's do it. I'm going to, make my picture. I'm going to plug in all my numbers. We're going to get an answer. 1250, 125 divided by the square root of 12. And then we're going to put in here 33%. Does that picture look about right? I mean, roughly. It's about what we're looking for. And we got an answer of 1234.126. Again, it's very close, but off by a little bit there. Okay. I want to see if I can interpret this correctly. So we're saying now that the average of the 12 factories together, if they're the lowest 33%, would be that much? Or no. I know. If a factory was to be in the lower 33% out of these 12, that's what their mean would be. Okay, I think that's a better interpretation. Newton is not going to do that for you. So if Newton's not doing it for your homework, then Newton won't do it for your quizzes, and Newton won't do it for your exams, and you're here to pass the class. Yay! So do you know how to get that number that they want? I hope so. I worry about myself sometimes, but hey, we're in this together. Let's say it again. How much worth? Oh, well, that's the thing. The highest 67 and the lower 33 are kind of in the same zone. See, this is 33, this is 67, right? It's that same cutoff line. It's like the line in the sand between the two. Does it make sense? Yeah, that was very good. And so we could have done the upper, so I would have done upper, well, there you go. Upper 67. See how it says 67 now? Exactly. Either way. Two sides of the coin, right? Yes, very good. So the average is this much. Standard deviation, that much. Bottom 15%, 200 homes. Let's do it, right? Let's do it. So some of these are easier than others, but let's figure out what my mean would be. So what's my mean? What do I put for my mean? Yeah, 400,000. Okay. What's my new standard deviation, what I'm going to be putting in the GeoGebra? Very good. Awesome. So let's do that right now. 41000 65000 divided by square root of 200, and we're wanting bottom 15%. So again, let me do a little quick graph. Bottom 15%. That's my picture. So I'm going to click around, change the second number here to 15%, and that's my answer that I got. I'm going to write that down, 405,236.351. Okay. So now let's answer the questions, right? They said, what's the new standard deviation? And well, we're looking at it right there. I should probably go and find it. Is there a way to like get that? No. Okay, here we go. So the new standard deviation, if I have to compute it off to the side, is this much. 4596.19. What's this X bar going to be? What would I be putting? Say it again. Yeah, the GeoGebra answer, exactly. The 405,236, right? Very good, very good. Now, what about the z-score? Again, I did it quickly last time. Let's do it again. I'm going to go a lot more slowly because, well, it's the problem that we're looking at. What I'm going to do is refresh the page. Refresh it, restart. 0 and 1. That's how you're going to find z-scores. But they're still wanting the bottom 15%. So what would the z-score be for that? See, it's the same location, but now it's telling us the z-score, which would be the negative 1.0364. That's what they're wanting there. So I guess because it's 2 decimals, it would be, well, not that, but 1.04. There we go. Cool. A little weird, but definitely possible. Good. 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 Okay. Cool. Okay. All right. Oh, and we're done. Yay. Let's go back to the homework. Can I finish it up? I want to go back and not cheat. Because, you know, I'm a big cheater. You're like, but what about all the things you cheated on, Chad? I'm laughing. So, has a mean of this much, 225,000. Standard deviation, 5,000. 50,000, sorry, 50,000. Divided by square root of what? 10. Very good. Move this over a bit. Yeah, square root of 10. Can I just get it all in one? Yeah, there we go. And they're wanting the lower 80% or the upper 20%. Either way, it's the same thing. It's just, you know, different views there. The cup is half empty, but it's also half full. Yes. And that should be my answer right there. That's what we got. 238,307.20. Awesome. So you're going to remind me now, how can I find the z-score? What do I do again? Refresh, start over. Yes, 0 and 1. Back to normal. And they're still looking for the what? The z-score? What do I change? Yes. I want to get that lower 80% again, right? That guy? And that's it. So whatever score they give you, 88419. Oh, again, 2 decimals. There we go. Hit it. Got it. So again, the z-score, just refresh the page, start over, 0 and 1. And again, they don't always ask for z-score, but when they do, now I know, just refresh the page, start over with 0, 1. Cool. Okay. Sweet. Did you use any of these tables? I wouldn't use any of the tables. I wouldn't use them tables. Okay, yeah, this one's one that we just cheated on, so let's do it together. What's my mean? 49.8. What's my standard deviation? Of the 39, square root of 39. Yep, right there. Good, good, good. And it says between 50 and 51. So between, I'm going to click the between button and put in here 50 and 51. There we go. So my mean didn't change. New standard deviation. I wish they would just tell me, like, you know, what's the decimal, you know? But here we go. 4.2 divided by the square root of, what was it? Yeah, 39. Thank you. Thank you. 6, 7. How many decimal places? 3 decimal places this time. Man, they keep going back on their word. One time it's 2 decimals, the next time it's 3 decimals. They just don't like us. It's like Newton wants us to fail. But no, we're going to show Newton. Yeah. You know what? You know what I'm going to do? Do you ever do this? I'm going to send some feedback. Yeah, I'm going to do it. Something's not right here. Yeah, it's the upside down face. Upside down face. You're like, what did that say? It keeps going back and forth on the 2 decimals and 3 decimals. Why? Someone's going to read that. All right. And it's their job to read that. Darn it. Okay. Psychologists research new blah 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 blah. Oh. This is one that I actually skipped. You see this right here? It says move the blue dot around. Okay, great. And yay and wee and woo, and that means nothing. This is not required. This is not required. This is what's required. This is what's required. So we're going to just do the same problem as ever. Look, we have GeoGebra right here. It's great. So look around. What is my mean? What's my mean? 300. Yep, 300. The 275, I think, is going to be what we check on here in a minute. See how it says it again later? What's my standard deviation? Very good. 59 over the square root of 45. Yes, very good. And then it keeps saying this less than 275 text. That sounds like a lot. I'm wondering why I didn't read it. So let's go and put in some stuff. My mean has not changed. My standard deviation, here we go. 59 divided by the square root of 45. Thank you. It's too many numbers to remember. You're like, but Chad, you're a math teacher. And then we got this answer right here. And you can see how tiny it is. That you can confirm that with the graph there. 3 decimals. 3 decimals. Submit. There we go. I'm not cheating this time. I know. What's the last objective? Oh, we already did this. We already did this quite a bit. Time to cheat! Yay! Boop, 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 boop. Time to cheat! Super cool! What's new? Is there anything else new? Okay, we're done. We just cheated our way to the top, guys. That's what we did. Yeah, that was awesome. Are y'all okay with this? It's fairly straightforward. I know sometimes it's a little weird, but generally straightforward. Okay. And I mean, we're not going to do too much here because, I don't want to go too far. But we're on track. If you just keep thinking that way, great. And next time we're going to do the chapter application. Okay, so on Thursday we'll do the chapter application together. So let's get a little bit ahead here so that we're keeping on track for the chapter 9 stuff coming up later. Confidence intervals. So I want to talk about it first, of course, because that's what I do as a teacher, right? Blah, 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 and then come back later, 5 minutes later. So here, I know something. So let's say that I'm gonna make a statement. I'm gonna make a statement. 50% of Americans are female. There we go. And it sounds legit, right? But you know how like guys die younger, like the women, they live on longer. I'm sorry, bro. We're in it together. But that's just kind of how it happens, I guess. So how confident am I in my stuff? When I say this, what kind of confidence can I put behind it? Did I just, guess at it, shooting from the hip? I just heard this in the news. Or did I do some statistical study and say, well, I'm 90% confident in my answers. 95% confident in my answers. If I said 95% confident, just for a second, what would be the not confident percentage? 5%. 5% not sure, basically. But isn't this right here unusual? So it would be unusual for me to be wrong. And that's a good thing. That means if I might be wrong. It might not be 50%. It might be 51, 52, whatever it is. But I'm 90-something% sure about it. And so that's that confidence interval. So how do we actually get a real interval of numbers that we could use here? Well, let me show you then. What if instead of saying just 50%, right down the middle, what if we had something like here and here? So let's say I'm going to give you a range now. Let's go with 45% to 55%. And all of this area in here is going to be how confident I am in my answer. So in a way, I'm going to say a new statement now. You ready? Not just 50. I'm going to say 45% to 55% of Americans are female. Sounds pretty good, right? And now I can actually have a range about what kind of percentage I have in there. And those numbers would be found by doing the math and et cetera, okay? So that's the goal. We're going to kind of find this range of values because I don't want to hit just one number. I want to say it could be anywhere around here. And I'm 95% sure about it. Cool? Okay. So that's kind of the goal, okay? All right. Awesome. Blah 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 blah. It says social network something site, 30 users, find the point estimate. Yeah, so they're just saying find the mean. Find the point estimate. They're saying find the mean. How do I find the mean of all these guys? Just take a guess. GeoGebra. Wow. So yeah, I'm not going to do that because they're just trying to make it funny. GeoGebra, find the mean. That's all they're wanting right there. How likely is it for the population mean to be exactly the same as the sample mean? Now, here's the thing. This is a sample of only 30 people, right? And I'm just going to make something up. If you don't mind, I'm just going to make it up. Let's say I've got 100. I'm just going to make it up, okay? So then this is my sample mean. My sample is 100. But then they're saying the population mean. Could it be 100? Exactly. Could it be 101? What if it ended up being 100.1? Are those exactly the same all of a sudden? No. So then I'm going to ask again, how likely is it that it's exactly the same? None. It's almost impossible because you're going to be off by a little digit, right? Somewhere. So like, yeah, I'm going to say impossible. It's impossible. And that's what this workbook is trying to say. I gave you that first example on my own. This is how they're trying to describe how we need like a range. We need a range. We can't just say the number. We got to have a range. So that's their point there. So intervals. Have any of y'all done algebra and done like intervals, domains, ranges, that kind of thing? So that's what they're talking about here. We're not doing negative infinity, positive infinity, but that kind of idea though should resonate in the brain a little bit. It's just going to be from this number to that number. And again, level of confidence, already talked about it. A nice, easy one is 95%, but they'll give you different numbers just to change it up. 95 is kind of a standard. Okay. Are we good there? You don't have to do algebra. You don't. I'm just, I was saying if you have had it, that's kind of what we're talking about. This is actually a big formula, and I don't really like the style of it, but that's why I'm going to give it to you here, okay? What they're wanting to say is that we have them, oh, you know what? Erase. I'm saying that my interval is going to be the mean plus or minus the margin of error. Margin of error, okay? So, as an example, there's my nice bell curve, and this is my mean. And let's say that this distance here, this is my margin of error. My margin of error. Okay, so then that range, that interval, that confidence that I have is from this end to this end. Let's do some real numbers with it, right? That makes more sense, real numbers. Let's say I had a mean of 100, but let's say I had an error of 15, let's just say. Cool. So then if I go this way, it's not 100 anymore. What's over here? Is it 75 or is it 85? 85. And then over here would be 115. So I'm going to now say, oh, what's the probability of 100? No, I'm going to say, hey, what about from 85 all the way to 115? And I'm blah, blah, blah percent confident in it. Okay. So the answer is between, I'm just making some English here, 85 and 115. And I'm blank percent confident in my answer. That's kind of the style here, okay? Whatever that number would be, 95 or something like that. Okay, so we'll do that as we keep going. So let's do some actual math. A student wants to determine the mean amount of snow in April. So they find the mean unknown because the record is not the same for every year. Okay, I'm understanding. So this little x bar is the sample mean, and then we have the margin of error. Let's not overthink it. They're saying just use the formula. So I'm going to do a lower and an upper value. Lower, mean minus the error. 26.25 minus 6. Take a guess. Yeah, there you go. And this is in centimeters. My upper is the mean plus the error, 26.25 plus the 6, 32.25, yep, centimeters. So there is my range, I guess you can say. There's my range, my interval. Okay, I don't know, whatever you want to call it, interval, range, something like that. They did not tell me anything about how confident they are. That's going to be later. Later, they're going to say 95% confident, and then we have to go and find the margin of error. But this is all going to be in GeoGebra, really. GeoGebra is going to take care of all of us. It's very simple, truly. It's probably easier than all the other things we've done already. But that's a good thing. A random sample of registered attendees were surveyed and asked blah, blah, blah about a survey. So then those who answered yes with the margin of error, so this is like the mean and the error, and they say, what's the confidence interval now? I mean, all they're doing, again, is taking the mean plus or minus my margin of error. So then I've got the 0.52 minus the 0.04 and the 0.52 plus the 0.04. That's all. How much would I have here? 48 and then 56. Very good. Now, you can express it in a whole lot of different ways. Sometimes they're going to want these parentheses, though I don't think the homework does this. And if it does, it might have like two separate boxes, and you just fill them in. Normally, I think I remember seeing like upper and lower separate, but we'll see. So yeah, you got your lower, you got your upper. Cool. Is this straightforward? Are we happy with this? Like, wow, good thing I didn't do algebra class. I'd rather do stats. I'm adding and subtracting. This is using the same formula, but to go and find the original values, which is still pretty easy. And then that was to be the end of the section. So, I mean, this is really straightforward. And I'm going to finish this up and be done. We're not going to keep going, okay? So these are 3 last questions, and they're very, very simple. They're saying find the mean and find the error given that you have these 2 numbers here, okay? So in a way, it's kind of like saying we have a number line at 3.5 and at 4.9. What's the middle? What's the middle value? And then how much were on either side, essentially, right? So I want to give you a formula for this, okay? There's formulas that Chad made. I'm Chad, hello. That I made, and it works out every time. I've got the upper plus the lower divided by 2. That's for your mean. And your error is your upper minus the lower, all divided by 2. Those are your formulas. This is stuff that you could put on a note card, essentially. Okay? I'm going to use them, too. Now, there's no way I can do this without Desmos or something like that. So I'm going to just real quick slide that to the side. Give me a second here. Get a little bit less room because we don't need it. Good. Okay, so clear all. Here we go. So here we go. I have 4.9 plus the 3.5 divided by 2. And then I got the 4.9 minus the 3.5 all over 2. And there you go. There's your answers. That's literally all you have to do. Does that make sense? Look back and forth. Would the middle be about 4.2? Makes sense. If I were at 4.2 and I wanted to get to one of the ends, would 0.7 get me there? That's it. That's all we're doing. It's very simple formulas. Are you okay with this? Yeah, I mean, I hope so. I want it to be good. So same thing here. Find the mean. Find the error. Sorry, error. Margin of error. Let's do it again. Yay! We're learning so much. Yay! Thanks, Chad. You're welcome. One last problem and we're done. It is this easy. It is. The homework is identical to this. It really is. Okay. Now, oh no, they say proportion. Well, they just mean the mean. I mean, yeah, it's so straightforward. Okay, hold on. Can I wait. Can I do no? Okay. Well, okay. Does anybody have any questions before we leave? I'm serious. I'm here for you. I don't want to over or underestimate anything here. Is this okay? Are we happy? You'd rather take this class than now algebra? You've been through algebra too. You're like, man, this is easy. Good. That's what I want to be. I want it to be easy. Because yeah, we did a whole lot. That was great. So we're gonna use GeoGebra next time, and again, it's super easy. It's all built in. You know what? Wow, keep packing up. Keep packing up. Don't let me stop you. But I do want to show you what it looks like because it's so fun and it's very simple. If you go here to this button called Statistics, see there's the two buttons you never notice over here, right? So Statistics, and we're gonna do Z estimate of a mean, I believe. See the confidence interval? And it defaults to 95, just like I've been talking about, right? So then you can say, like, I want a mean of this. I have a standard deviation that. And I'm looking at like 30 different people, and it gives you all the numbers you ever wanted. It's just that easy. But we have to interpret. That's going to be the future goal, is interpret what they're talking about. Good? We're done. See ya. Thank you, guys. Bye-bye. Stop recording.